These two triangles are similar, ABC and EDC, and if this one has 3 and this one has 6, we are multiplying by 2 as we go from one to the other. We also know that these angles are congruent, meaning they're the same. So if this entire distance is 15, there is a 2-to-1 ratio for these distances. So 3x is 15. CE is made up of 2x, so since x is 5, we plug that in, and the answer is 10. Triangle ABC is isosceles, and AB is equal to BC, and the bottom leg is 48. And the ratio from DE to DF is 5 to 7. So we could consider this 5x and this 7x, and we could add them together and say that 12x is equal to 48, so x is equal to 4. If we wanted to find DC, we plug that in, 7 times 4, and we get 28. ABC is similar to EDC, BAC corresponds to CED, and ABC corresponds to CDE. Which of the following must be true? Well, both of these angles are along line AB, and both of these angles are along line DE, so these two are going to be parallel to each other. If they weren't, these congruency relationships would be impossible. The opposite interior angles being congruent means these are transversals that are crossing parallel lines. Here's triangle ABC. If we say that AB is congruent to BC, two side lengths are the same, so it is isosceles. Another property of isosceles triangles is that the base angles are congruent. Angle A and angle C are the base angles. So in that case, we also know it's an isosceles triangle. So either one of these things is sufficient. Here's triangle ABC. Angle A here is 23 degrees, and angle B is 97 degrees. In triangle DEF, D matches up with A, and E matches up with B. No additional information is needed to prove that these are similar because the interior sum of the angles have to be 180 for any triangle. So if two of them are the same, the third one has to be the same as well. So given in number 9, we see the angles 35 degrees. Therefore, this other angle is going to have to be 110 for both of them because they have to all add up to 180. So we already know that the two triangles are similar because the angles are the same. So we can cross out D and A. BC and EF are corresponding side lengths. If they were equal, then it would be congruent. AC and DE are not corresponding side lengths. Notice one is between 35 and 110, the other is between 35 and 35. So B is the only one. So there's a point F placed so that triangle ABC is similar to DFE. What I noticed is that this original triangle is doubled in size and then flipped across the x-axis. So all the coordinates are multiplied by 2. This becomes 8, 4, this becomes 2, 2, this will become 4, 10. And then the y-coordinates are flipped to become negative. So that's why B is the right answer. I'm going to draw a line right down the middle here, creating a 90-degree angle here. And this 32 is cut in half into 16. Now I have a right triangle. I can use right triangle trigonometry. Cosine of x is going to be 16 over 24, adjacent over hypotenuse. I can simplify that to 8 over 12, or all the way down to 2/3. If x is 60, we have a 30, 60, 90 triangle. Across from 30 is 4, across from 90 would be 8, or 4 times 2, and across from 60 is 4 times root 3. They want to know AB, the answer is 8. If you didn't have 30, 60, 90 triangles memorized, you could say that the cosine of 60 is equal to 4 over the hypotenuse, or hypotenuse is equal to 4 over cosine 60. And that would also give you 8. So if you consider we're looking at two different triangles, and the first one is the big one, ABC, and the second one is this smaller red one that is inside of the other triangle. With this first ratio, we look at the second and third longest sides of that blue triangle, and we're looking at the second and third longest sides of the red triangle with choice A. If you pay close attention to which triangles we're comparing and their orientation, you'll find problems with all of the other three. Triangles ABC and DEF each have a corresponding angle measuring 40. What else do we need to know to determine that the triangles are similar? Well, as long as you know that at least one more pair of corresponding angles is the same, then you can conclude that all three are the same and that the triangles are similar. The side lengths would just have to be proportional, and we would have to know all three. So if we're sticking with angles, we need to know at least two corresponding angles are congruent.